So let us have the probability. So the theory of probability, or the study of probability, started uh, in the 17th century when the two French mathematicians Blaise Pascal and Pierre de Fermat consulted by the gamblers regarding how likely they will win in a game of chance. So when we say probability, it refers to the game. So how many number of chances you have. Okay, so it appears from the earliest centuries that the probability comes from gambling. But now, the time here, we cannot, probability, okay, is not only, it's not only used in gambling, but also we can use them in other areas uh, in real world. For example, if you are predicting, if you have upcoming typhoon, okay, in the economics, okay, and science, so we can use the probability. Okay, these two mathematicians here, Blaise Pascal and Pierre de Fermat, are the pioneer, or the one who documented the scientific study of the probability. Later on, they developed a theory of probability. Okay, so this is the probability, and a probability is a branch of mathematics that provides the quantitative description. Okay, so meaning say we are dealing with numerical chance. Okay, or the occurrence or of the likely occurrence of a specific event. So this is the probability line. A probability line is from 0 to 1 only. Okay, or in percentage, that is from 0% to 100%. So if it is 0%, that is an impossible event. It will never happen. And if it is a certain event, okay, or that is a sure event, okay, if it is a sure event, it meaning to say it is likely, most likely will happen. Okay, and between 0 and 1, we have the chances. Okay, there is also a percentage that 16% that it will happen, 15% that 50% that will happen, or 66% that will happen. Okay, so we have the different terms in probability. When we say experiment, refers to any situational activity that involves chances. Okay, so what are they? So what is an example of experiment? Experiment is, like for example, tossing a coin. Okay, tossing a coin, rolling a die. Okay, that is a situational activity. Ayan, no? Where it says situational, meaning to say tossing a coin. You toss a coin, you roll a die. Okay, that is an experiment. The name of an experiment. Okay, situational activity. Okay, how about the outcome? Meaning to say that is the result. Okay, or the possible result of an experiment. So what will be the result from this experiment? So how many possible outcomes are there if you toss a coin or roll a die? Okay, how many possible outcomes? Okay, how about sample space? Sample space is a complete list of all possible outcomes. So it is under the outcome. So we will say complete list, the complete list. Okay. So in denoting a sample space, we can denote this at n of s. Okay, and then put a brace, and then and then you list down all the possible outcomes from that experiment. Okay, from that experiment. Next, event. Event is the subset of sample space. So, what are the example of an event? Event and experiment are different. Okay? So, sample space, that is the universal set. Okay, actually. And the event is only a subset of the sample space. Okay? So, for example, an event, you need to toss a coin. Tossing a coin, wait, uh, let's, for example, we have this example, getting getting a prime number, uh, getting ahead, getting ahead, getting ahead in uh, coin toss, in tossing, or in tossing a coin once, in tossing a coin once. Okay, see the difference between the experiment and the event. Okay, so meaning say you need to get a result of a head. Okay, meaning to say, if you have a sample space of, the sample space of n of s is equal to, if you toss a coin once, you will get two results. Is it either heads or tails? Okay, now your event is n of e. The number of event is only one, getting ahead. So you need to get ahead. So okay, so this is the universal set na h of t, h and t, and this is the number of event, that is h. Okay, you need to get ahead. Okay, so the sample space is the universal set, and the event is subset only. Okay, next we also have a sure event, another other terms. So self-explanatory. So when we say sure event, these are surely happen no matter what. Okay, for example, the rising of sun every morning. Okay, so when we say impossible event, this is an event that will never happen no matter what. Okay, what are they? So for example, uh, a man can fly. Okay, that is an impossible event. We all know that a man couldn't fly. Okay, and a certain event. Okay, so this is between the 0% and the 100%. That is the uncertain event. So there is also a percentage that will happen. For example, tossing a coin. Okay, if you toss a coin, toss a coin, okay, and getting heads, tossing a coin, and get ahead, okay, get ahead. So we just say you will get, this one is an uncertain event. There's a possible chance that you will get ahead when you toss a coin. Okay, uncertain event. Okay, so now I will teach you how to count, okay, the number of possible outcomes.